This is an AQA GCSE chemistry question. It's from the Trilogy 2019 paper and it is a foundation question. It covers bonding and chemical changes topics. I'm going to recommend you pause, have a go at the questions and then review. So here is part A, part B and C, part D, part E, part F, and part G. 13 marks in total. So let's start with part A. We have got a table to fill in. You'll get 1 mark for each of the columns. So Cu is copper, and we also have got oxygen in there as well. We know that from the formula. We can then add the remaining symbols. So sulfur is capital S. It's in the formula. Remember, you have a periodic table as well. Oxygen is O. And then we're looking at how many coppers and how many sulfurs there are. And there's 1 copper and 1 sulfur, and the 4 oxygens are already in. On to part B, complete the word equation for the reaction between copper oxide and sulfuric acid to make copper sulfate and water. All of the information is provided. All you've got to do is put them in the right places. So copper oxide and sulfuric acid are reactants, so they go on the left-hand side of the equation. We're making copper sulfate and the water is already included. What type of substance is copper oxide? Well, it neutralizes an acid, but it doesn't dissolve in an acid. We don't actually have an option for an alkali, which is a soluble base, but it is a base. For part D, we have got a method here. There is an important piece of information. You do need to read through all of it, but we are told that we're adding copper oxide, warming with sulfuric acid, and at the end, not all of the copper oxide has reacted. So, if that's the case, we are still going to have black powder. That means that we're going to have either answer number 1 or answer number 2. Now, there is a reaction that's happened, and we have evaporated the water. So we are going to end up with the blue crystals of copper sulfate and the black powder. So this is the correct answer. For part E, in terms of a diagram, it needs to be 2-dimensional, it needs to be cross-sectional, and what I have got here so far does do that, but I haven't labelled it. So I need to label my filter funnel, my filter paper, my beaker, and I need to label the excess copper oxide that has not gone through. There would be copper sulfate solution down here as well. For part F, what equipment should the student use to measure 2 grams of copper oxide? Well, if you're measuring a mass, you're going to use a balance. If you're measuring a volume, well, you could use a beaker or a measuring cylinder, but you would always use the measuring cylinder because it is more precise. On to part G, we've got 1 gram of copper sulfate dissolved to make 25 centimetre cubed of copper sulfate solution. What's the concentration in grams per decimetre cubed? Well, concentration is mass divided by volume. So I've got my mass 1, I've got my volume, but you'll notice I've divided by 1,000. I've converted my cm cubed to dm cubed. I put all of that in and I get 40 grams per decimetre cubed. And that takes us to the end of this question.